let's just do a couple more problems with some other geometric shapes, since we've used triangles both times so far. The radius of a circle is decreasing at a constant rate of 0.05 meters per second. What is the rate of increase of the area of the circle when the radius is 2 meters? Okay? Radius of the circle decreasing at a constant rate, so that means dr dt. What is the rate of increase of the area? That's going to be, let's call it dA dt. You can pick other letters if you want. You just want to have something that's representative of that. So we can draw a circle. A circle just has this radius r, and we want something that's going to relate r to area. Well, we know that the area of a circle is pi r squared. And that's got our a and our r, so that's looking good. So that means we can take the derivative with respect to t. Remember, pi is just a number, it's just a constant, so we don't have to do the chain rule for it. It's just along for the ride. We're going to do the derivative with respect to r, so that's 2r. And then that funky chain rule. Okay, so we can look at our knowns, unknowns. We want to find dA dt. We know the radius of the circle is decreasing, so dr dt is decreasing. So decreasing means that it's getting shorter, it's moving in the negative direction, 0.05 meters per second. And we're told that the radius is 2 at this particular instant. Okay. So we can plug this in. Pi times 2, r is 2, dr dt is negative 0.05. And if we multiply all that together, that's negative 0.2 pi meters squared, because that's the units for area, divided by seconds, because that's our units for time. Okay, one more problem. The surface area of a sphere is increasing at a rate of 10 centimeters squared per minute. At what rate is the radius increasing when the surface area equals 100 pi? Let's go ahead and make that a check for understanding problem. Go ahead and try that one on your own and then restart the video when you're ready. Pause the video now. Okay, so surface area increasing at a rate of, so this is ds dt. Let's make s for surface area. At what rate is the radius increasing? That's dr dt. So what we have is we have a sphere with some radius r. And now we need to know a couple of formulas, and I'm going to give you a list of formulas that you need to have memorized on the back. But one thing to note is that the formula for the surface area of a sphere is S equals 4 pi r squared. Just is, you just got to memorize it. We're interested in rates. We related S, we related r. So take the derivative with respect to t. The 4 and the pi are just constants, so they're along for the ride. Bring down the 2. Do the funky chain rule. Okay. So ds dt is 8 pi r dr dt. So our knowns, surface area increasing, so that's a positive ds dt, 10 centimeters squared per minute. At what rate? Unknown. Is the radius increasing? dr dt is unknown. When the surface area is 100 pi. Okay, so we come to plug these in. ds dt is 10. We've got 8 pi. Looks like we don't have r, so we're going to need to find r. And then we want to know dr dt. Well, we know over here that S equals 4 pi r squared, and we do know S. So 100 pi equals 4 pi r squared. Divide both sides by pi. Divide both sides by 4. Now we can take the square root of both sides. Because we're dealing with distances, we're only going to keep the positive, even though this would typically be a positive or a negative. So if r is 5, then 5 goes right there. (10) equals 40 pi dr dt. Divide both sides by 40 pi. One over 4 pi is the exact answer, approximately equal to 0.0796. For our units, we're interested in r. The r radius is centimeters, because we're doing a centimeter squared up here. The t units are minutes, centimeters per minute.